Hi guys, welcome back. We're going to do an application of what we learned in a previous movie, the energy use related to phase change. I want to talk about how much energy it will cost to bring 180 grams of ice of -10 up to water vapor with a temperature of 105 Celsius. So I have all the information on the board here. Here we see all the heat capacities for ice, water, and water vapor. The heat of fusion, so to melt, and heat of evaporation, so to turn water from liquid to a gas. Here you see 180 grams of H2O from -10 to 105 Celsius. Sometimes we can apply Q as mc delta T when we have a delta T. To calculate the total energy assessment, we have 5 steps according to the diagram, the heat diagram. First step. We have to bring the ice from -10 to 0 Celsius. So we have a delta T, 10 Celsius. We can apply the formula mc delta T to assess the energy used for that step. Let's do that. 180 grams times 2.08, that's the heat capacity of ice, times 10, that's delta T, -10 to 0. We do it correctly, it's 3,744 joules. Now I have my ice at 0 Celsius. Next step is to melt 180 grams of ice, still at 0 Celsius. At the end, I have 180 grams of water of 0 Celsius. I cannot apply the formula because I don't have a delta T. But I have a heat of fusion, 6.01 kilojoule per mole. But I don't know how many moles I have. But I know I have 180 grams. So let's do that. 180 grams divided by 18.01, that's the molar mass of water, is 10.0 moles of water. That's what I have. So, and now I can multiply the 10.0 moles with my heat of fusion, 6.01 kilojoule per mole, and that is about 60.1 kilojoule. I'm going to convert it immediately to joules because at the end I want to add everything up. So, and for this step, I need 60,100 joules. After step 2, I have all my H2O at 0 Celsius liquid. Third step is to bring 180 grams of water from 0 Celsius to 100 Celsius. So again, I have now a delta T, 100. I can apply the formula again. The formula, let's do it. 180 grams M. C is now 4.18, is the value for liquid H2O. Times 100, delta T. We do it correctly, it's 75,240 joules. At the end of step 3, all my water is at 100 Celsius. And now I have to evaporate everything. So the 180 grams, or I have 10.0 moles, already calculated that. And I have to use the heat of evaporation that's expressed in kilojoule per mole. So what I do, so Q is 10.0 moles times 40.6 kilojoule per mole is 406 kilojoule. And again, I convert it immediately to joules. 406,000 joules. That's a lot. You see, that's even more than all the previous steps. So the evaporation costs a lot of energy. My final step is, I have now water vapor at 100 Celsius to increase the temperature of my vapor from 100 to 105. I have a delta T. So what I can do now, I can apply the formula again. And let's do that. So I still have 180 grams. 180 grams times the value for water, the heat capacity of water vapor, 2.05 joules per gram Celsius, times delta T, and delta T is 5. I go from 100 to 105. And when we do that correctly, that's about 1,845 joules. So we have now the energy use required for all the 5 steps. So my total energy, just add up everything. So 3,744 plus 60,100 plus 75,240 plus 40,600 plus 1,845. And you do it correctly, it's 546,929 joules. That's to bring 180 grams of H2O from -10 to 105 Celsius. If I do the other way around, if I start with water vapor of 105 Celsius, also and I have 180 grams, if I want to bring it back to -10 Celsius, it's the same, but then it's a negative value. So from 105 Celsius to -10, it will be minus 5,446,929 joules. Then I start with 105, go back to 100, so that delta T is then -5. So then I will have here the same value, but then with a negative sign. Alright guys, what I suggest, what you can do now, review the other movie as well, read the book, look at the presentation online on Schoology, and I have a nice worksheet for you to practice. Probably we're going to come back with another worksheet to practice a little bit more on Friday. That's it for now. Take care everyone. Bye bye.